All right. Hello, everybody. Hello, Java fans. Hello, software engineers. Indeed. Hello, AI engineers. How are you guys? Really happy to have you here. And also, really also so pleasure to have Eric in the second part of this talk. It's been like an incredible journey in the first talk, so we will be, of course, talking more about this second part in a while. But on behalf of you guys, I would like to really thank to Eric for accepting this invitation and also being in the second part. Eric, how are you?
I'm doing pretty good. It's been a when was I here? In July? It feels like it was yesterday.
Yeah, yeah.
Yeah,
Yeah.
so
So
so we've gone through. I had just joined IBM, I think, last time I was here, but I've actually changed roles within IBM since then. So I've
great.
moved into the engineering. I'm actually on the Quarkus engineering team now.
Nice. Awesome. Very good. So I think we did this the first part in the I think it was like at the end of the summer, and I think now in the autumn. So it's like transitioning of the weather from the first part and second part. So I think also I don't hope that there's much of this transition happening in the AI side also in this couple of 2 months. Yeah. So
I was
yeah.
going to say this. I've been in industry for a long time, and I've never seen like the pace of change as to what we're seeing right now. I've been doing this a long time, and there's probably enough to have a part 3 at some point too, if we start getting into agentic and all that stuff.
Yeah. I think we're gonna make it part then question mark. We didn't know. Yeah. So guys, before we jump into the second part, I'd like to give a brief intro about Eric. Eric is actually a Java champion since being in the market for decades, and senior principal engineer working for IBM now. And he's really into the Quarkus and into the AI stuff. So I recommend you guys to follow him on LinkedIn, Twitter, and all other social media. Here in Java user group, we conduct and organize online talks and also in-person talks. Uh, so we'd like Eric kindly please to give us and the audience also a brief recap about the first part before we jump to the second part. Uh, then roll out the to this part two. So any questions, guys, please drop them in the section below. And also, we will be sending the recording for the first part for you guys in order to watch both of them. So everything is recorded. Stage is yours, Eric. Good luck.
Break a leg. So I'd say if any comments come on, just please bring them to my attention, because the way I've got my screen set up, I may or may not see the chat live here. I'll try my best. But again, thank you for the introduction. Just a little bit about me, and I know I did this last time, but in case you didn't see the first part, I'm based in the U.S. I'm a Java champion. I've been doing software engineering for a long time, mostly before working for Red Hat and IBM. I worked for financial services companies. I've always been a contributor to open source projects. I was saying at the beginning, I've actually changed roles within IBM in September. So I'm now actually part of the Quarkus engineering team. So my job is to make Quarkus awesome. I do work on LangChain4j and the Quarkus extension for LangChain4j as well. We've got this new, if you're familiar or if you're not familiar with it, this project called Dockling is and I'll talk a little bit more about it when we talk about RAG. but for document parsing, for AI, for ingestion into your RAG pipelines, there's an open source project that's written in Python called Dockling, and I'm now the lead on a Java, I'm not gonna say a Java version of it, but a Java API for it. It hasn't been released yet. It just started, but it's gonna be cool when it's there. So keep your eyes on that. And I am involved in my local Java users group as well. So I'm based in the Boston area. So I'm the co-chair and help organize my own local Java users group. So this is a great way to get involved in your local community, whether it's in person or remote. It's a good way to make friends. It's a good way to stay educated and to have informal conversations with people. So I'm look forward to that. Kind of like last time, there's tons of information that you're going to get here. I know I said we probably wouldn't finish the first time. Hopefully we'll finish the second time, because there's probably already a third version of this that I haven't finished polishing up yet, that is all about agentic AI. We'll kind of lead into that a little bit towards the end of this, but I don't think I'm going to get into some of the agentic patterns, because there's a whole separate part of the frameworks in LangChain4j for doing agentic AI. All the example code is there. The slides should be available with that QR code. And then there's also a hands-on workshop where all this stuff that I'm going to talk about lives. So I think I watched like the last 5 minutes of the last one beforehand. I think if I can see my mouse here, we got down to the RAG section. So we got about halfway through this list, if I'm not mistaken. So we covered kind of some of the generic or the general AI concepts. We covered chat models and AI services and auditing and memory management and image models and all that. Does that sound right, Muath? Sorry, I know you probably weren't waiting to be called up on again.
Yes.
All right, so I am going to jump in. I'm going to just go through one little thing in the auditing section, because this is actually kind of new in LangChain4j since the last time we talked. And I'm just going to find the right slide here. I talked a little bit about auditing, structured output memory. I just gotta find the right slide here. Yeah, so auditing. So when we talk about observability, I'll talk a little bit more about it, but I wanted to mention this is something that's built into LangChain4j now. Whereas when I started talking about this last time, it was just in the Quarkus extension for LangChain4j, but right now this actually exists in the upstream LangChain4j. So this is the ability to keep track of what your LLM is doing. So if you think about a round trip of a request, so say you want to ask the LLM a question, you might ask the question, maybe there's tool invocations, maybe there's guardrails, and we'll talk about what guardrails are in a little bit, but essentially that one interaction can cause many round trips to the LLM. And if you want to be able to monitor that, or keep track of that, or audit that, or look at your observability stacks, there's now a way to do that. There's a set of events that LangChain4j will fire that you can listen to or register to listen to when these events happen. So like when the invocation starts, anytime a response is received, anytime there's any kind of an error, when the total response is completed, when your operation is complete, when a tool executes, and then we haven't really talked about guardrails, but when guardrails get executed, the outputs of that, whether they were successful or not. And then you can start to capture this. And I have a whole separate talk about how do you know if you make a change, how do you know if you got better or worse? And I'm going to debut that talk at JFocus in February in Sweden, but it's going to use a lot of this stuff to capture events and be able to do playback and recording of your interaction, so that you really have a good fundamental idea of what your system is doing. And so this is pretty easy stuff and pretty good stuff. And if you look at it from the Quarkus perspective, and I'm just going to skip slides here. From the Quarkus perspective, oops, I got to update this slide. I forgot to update the slide, but essentially all those same events, you don't have to build. We make it a little bit easier. And I know the names of the methods here. I got to update the slides, but the those same events get fired, but because Quarkus uses CDI, you can use CDI observers to observe those events. You don't have to implement a listener and then register your listener to do that like you would in the upstream. Quarkus will just fire the events and you can listen to them through CDI events. And so all the same events, it's the classes that it uses are actually the same ones from LangChain4j. Quarkus doesn't invent its own classes or anything. It's all the same stuff. So that's kind of what's new in there since the last time. So I just kind of wanted to highlight that a little bit. So let's kind of shift gears a little bit and let's talk a little bit about RAG. So RAG, if you are or you aren't familiar with it, stands for Retrieval Augmented Generation. So this is a pattern or something you would do to enhance knowledge that the model you're talking to doesn't have. So one way to do that is to fine tune, right? You could take your model and you could train it on additional data. And then now that model knows about whatever that additional data is. The other way to do it without having to do fine tuning is to do retrieval augmented generation. So this is to be able to enhance the knowledge by first going out and querying some other data somewhere else and then passing that over to your language model so that your language model can use that additional information when it's formulating a response, right? And there's two stages of the retrieval augmented generation, and most people when they do demos, including myself, combine these two stages in a single application because it's easy to do. But generally speaking, in a production environment, you usually find that these two stages are separated and they're not done by the same applications. They happen in different time periods. They happen at different slots. There's different ways to do them. The first stage being the ingestion or the indexing part, so getting the data into the system. And then the second stage is retrieving it, fetching it, and passing it to the language model. So if you think, I like to kind of think of it as almost like ETL. So if you're familiar with ETL, you're doing batch jobs and batch job processing to push data into a data store. That's kind of what the indexing or the ingestion part. And then the retrieval part is in your application when your users or your applications need access to the data, they're going and fetching it. So let's break that down into kind of two separate stages and let's look at the two separate steps independently from each other. So the indexing process usually happens out of band, meaning the end users typically don't wait for this to happen. So usually it happens through some kind of process, whether it's a CI process or a batch process. I've seen customers do this. They use event-driven processes. So maybe they've got a transactional database and they're using a pattern like change data capture to capture the transaction logs and publish it to a Kafka topic. And then they have a listener listening for messages on Kafka and that are doing incremental updates through this pattern as part of that. Or there's some weekly batch job, or there's something that can do this. I see somebody's asking for the link to the presentation. I can drop that in the chat too. Let me go back to my first slide. Yeah, the link is right here. Oops. So if you take a picture, and I'm going to get out of presentation mode. Yep, someone's asking for the slides. I'll drop this right in the chat. Here we go. I don't know if it'll let me. Nope, it won't let me. So I'll drop it to Muath in the back, and he can post the link. There you go. Hopefully that helps. All right. Boop. There. Now let's go back to the slide I was on. Boom, boom. Bear with me 1 second. I'm trying to find the right slide I was on. There we go. Sorry about that. So this is pre-processing. So the end result of this is you've got some data that is somewhere. Maybe it's in a file. Maybe it's on OneDrive, or it's on a website, or it's on your internet. It's somewhere. You've got some data somewhere, and you want to get it from its raw form into this queryable form, which we'll talk more about what vector representations and what vector stores are. But essentially, you want to get this data, you want to chunk it, and you want to split it and put it in this store. So from a technical perspective, this sounds pretty easy. And actually, the technical part of this is the easy part. It's figuring out the right way and the right way you want to process these documents, which is the hard part. And it's somewhat of a non-technical conversation. So from LangChain4j's perspective, you have these documents somewhere, and there's lots of different ways and building blocks that LangChain4j gives you to be able to access these things. So whether they're on your file system or in your class path, or available via some URL, or on some S3 storage or Azure blob, or whatever. There's lots of different places that these things can be. So there's these loaders that know how to load and parse these documents, whatever kind of documents they are. And once you load them, then you need to parse them, right? And this is, you kind of have to know the structure of your document, because the old saying of garbage in, garbage out, right? If you parse this and what you get out of the parsing is garbage, you're going to put garbage into your system, and then when you go to query it later on, you're going to get garbage out. So that the data that you get out of this is only as good as the data that you put into it. So this is kind of where you have to have an understanding of the data that you're parsing, and parsing it in a way that makes sense. So if it's a text document or PDF or POI, and this is, I talked about dockling before, this is a place where dockling could come in. Part of what we're doing with the dockling Java project is building a bridge and an integration between what dockling does and the document abstraction that LangChain4j has. So it's not there yet, but it's in the works. So dockling is super powerful about what it can do and how it processes documents, and how it understands the relationships between the elements in your document. So if you think about just for example, a PDF document could be a book, right? And a book has a table of contents, and then you can drill down into sections, and each chapter has a section, each section has subsections, and those subsections might have graphics or images or figures or tables or something. You want to be able to parse this data in a way that makes sense. So if a user is searching based on text, you want a textual representation of everything in that document and the relationships between, if you're in the last sentence of one chapter, what's in the next chapter might not be necessarily relevant, even if they have similar words in the sentences, if that makes sense. So semantically being able to process these documents. And this, I find, is the hardest part of all of this, is figuring out what's the best way to process the document so it makes sense when you go to query this. And you might parse the same documents in multiple ways and publish the results in multiple vector stores based on who your consumers are. So if you think of the CQRS pattern, where you have a read model or multiple read models and a write model of representations of your data, you might do something like that here. So it can get pretty complicated. So again, what do you need to think about? What's the representation of data? How do you want to split it? So if you think about, you've got this chunk of text, say you parse, you've got an entire paragraph. Well, that might be way too many tokens or way too much data. If you're just searching for one small thing, you probably don't want a whole paragraph. You probably only want a sentence or two, but you probably want some overlap between those sentences. So, one sentence in a paragraph is probably has a relationship to the next sentence in a paragraph from, a semantic perspective. So you need to figure out how much overlap, and you generally want to store the overlap between those sections when you're parsing them. And the LangChain4j has all the building blocks to do this, but like I said, the how to do it is the hard part. Doing it, once you figure out how you want to do it, actually doing it is the easy part of this. So like I said, LangChain4j has different splitters for doing different things. So if you want to split your document by paragraphs, by lines, by sentences, by words, by characters, by regular expressions, or the catch-all, I just want to just do a default, which is what everybody does in their demos, and is probably the worst thing that you could do, because it doesn't really pay any attention to how your documents are split. And when we start to integrate dockling into this, there'll probably be some more of these things that work with dockling. Dockling has a lot of capability, which is pretty cool. So once you have that, and once you split it, so what are the use cases for RAG compared to fine tuning? So it's kind of like you would, if you want to ask questions, and say you want to ask questions about your private data, you work for a financial company and you don't want to send your data to ChatGPT, so maybe you host an internal model, or you don't necessarily want to fine tune your model because maybe this data changes, right? So maybe this data changes weekly or monthly, so you don't want to bake it into your model, but you still want you to be able to have your model understand the data and be able to use the data to formulate responses. So you would use the RAG pattern in that use case, because you can use this as I kind of get through the pattern, you'll kind of see how it starts to work. Once you have that data, then you need to calculate an embedding. And if you think about it, it's a highly mathematical computation. So if you think about your data and you're going to plot it on a graph that has in different models use a different set of dimensions. So I think ChatGPT uses like 1,536 dimensions. So it plots this graph with 1,536 dimensions of different points, and each segment or each token that you plot has its own unique representation on the in the graph. And so when you compute this allows you to plot these different vectors, and then to be able to search vectors later on to see which vectors are most similar to other vectors. So computing this embedding requires yet another model, an embedding model, and there's lots of them out there that do this, open source ones and paid ones that do this. And so once you have your segment and your embedding, then you need to store that. And you typically store that with some metadata and with the actual text segment as well, because you don't want to have to do that computation reverse. You always want to store it with the actual segment that was used to compute the embedding. And there's lots of different stores. In memory, Milvus makes one. There's a plugin for Postgres called PG Vector, Pinecone, Oracle can do this. There's lots of different vector stores out there. So it's essentially a database, but it's a database that provides capabilities for storing these dimensions. And someone's asking, explain the dimension. So I'm not a math person, but so let's just pretend there's two dimensions, right? So a dimension, so I like animals, and maybe I'm reading a book about animals, and maybe the book is about cats and dogs. So my model might have two dimensions: how cat-like is it, and how dog-like is it, right? So one of the criteria could be it's fluffy. Well, a dog could be fluffy, a cat could be fluffy. So that plot would be kind of somewhere in between or near the dogs and the cats. But I could say, oh, it barks, right? The attribute of barking is more towards a dog than it is to a cat. So it would get plotted on the graph like that. And then when you go to search, so say, I want to run a search, it will search for things that are close to either dogs or cats. And you have to, it's hard to visualize like a more than two dimensions in your head, because humans aren't really good about visualization, right? So if you think about all the text that could be in a particular document, each model has its own different, it computes all these different dimensions. So there could be like 1,500 different dimensions or characteristics of the data as to how one piece of data is related or not, or unrelated to another piece of data. I don't know if that explanation helps, but that's kind of the best that someone else explained it to me. But at the end of the day, it's a mathematical computation, which is a way to express semantic similarity between two things. And the example I like to use is like apples, for example. So I live in the US, I live in New England. This time of year, it's a great time of year because it's apple picking season. So if I were to ask an LLM about what apples are good to be picked at this time of year, Apple Computer usually releases its new versions of phones and operating systems in September, October as well, right? So if I ask what kinds of apples are being picked now in New England, I don't want to know about iOS 26 or Mac OS 26, right? I want to know about Honeycrisps and Fuji apples or Granny Smiths or whatever kind of apples you like. So thinking about like a question like that, being able to understand the semantic difference between the apple that grows on the tree and the apple that's made in California with all the adapters and stuff that you need all the time. I don't know if that makes sense, but at the end of the day, this is kind of, it's like confusing, right? So like I said, the code to actually do this is the easy part. It's figuring out how you want to parse is the hard part. So in this example here, this is just straight LangChain4j, I can build an ingester. I need two things. I need the embedding model that's going to compute the embeddings, and I need the store of where I'm going to put those embeddings. I can add data to these documents. So in this case, I might maybe a particular document is related to a particular user. So maybe when I do the searching later on, I want to filter the data that I'm searching for by certain criteria. In this case, maybe I am, a particular user is asking a question, so we only want documents that are related to that user. So you can add metadata to these documents when you ingest them. And then you split them. So in this case, we just picked randomly. We want segments of 1,000 tokens with a 200 token overlap. That line is probably the most important line because that's going to determine how you do your splitting. And that's where you probably need to, even though it's one line of code, is probably where you need to put the most thought. You can do other things like it's usually good to have references to things. So if say you were scraping your intranet and you had URLs on your intranet and you were scraping data, you probably want to store the URL to that document. So when you return it later on, maybe your user asks you, show me where I can get more information about something, you have a reference to it. So that's what this text segment transformer is doing, is it's adding metadata to the document. In this case, the location as to where the document came from, or its file name, or whatever. That's just an example. And then the loading part is a kind of a one-liner. You tell it how to load these things, whether they live on a file system or you want to load them recursively or from a S3 bucket, you want to do a web search or whatever. And then you just ingest them, and that will do the splitting. It'll ingest them and it'll put them in the vector store. So that's the code is the easy part, right? So now your data is in this vector store. Now you can actually use it. So I kind of look at this like think about your application uses a database. You don't necessarily care where the database came from, who's maintaining it, how the data got in there. You just know that when your application starts up, there's a database somewhere that has data that you can reference. It's got a schema and you can reference that. And that's kind of how I look at this. So when your application starts up, there's some database that has a vector store that's available somewhere. So now to do the augmentation, what you first need to do is say the user or the system asks a question like, what apples are good to pick at this time of year. The application first needs to go to that same embedding model and compute the embeddings for whatever the question was. And then you query the vector store. So the vector stores have their own APIs. It's kind of like SQL, but kind of not, where you can say, give me the number of segments that are relative within a certain percentage, 75% relative, and give me the top 3 or top 5 or whatever segments that are relative semantically to the question. And then once you get those segments back, you do what's called prompt stuffing. You take the original prompt, and then you add additional data into it and say, oh, by the way, when you go to answer this question, use this data. And then you throw in the textual data that you got back from the vector. So now the LLM has access to that data because you are basically handing it to the LLM to say, here's that data, right? And the retrieval part is actually pretty easy. So in Quarkus, if there's this class called a retrieval augmenter that's actually part of LangChain4j. You tell it where your embedding store is, where your model is, how many results you want, what you want the score to be. If you want to do any filtering, remember when we put the data in, we could add metadata. So here you can filter based on metadata, and then you can tell it how how to retrieve that, and there's just a default implementation for that. Yeah. So what if the data is huge before you send it? Yeah. So you got to keep in mind here the number of tokens. And this is where the data that you put in is important, right? You don't want to put in huge amounts, huge text blocks, right? You want to token it so that it's small but also meaningful, right? You don't want to split a sentence mid-sentence because the first part of the sentence could be context matters, right? You could, by splitting a sentence in half, you could lose the context of what the sentence could be. There was a good example of this I saw in a talk. I don't have the slides, unfortunately, but they're talking about how context matters. So it's part art and part science. So you don't want it too huge, but you don't want it too little either. And that kind of going back to here, looking at this line of actually doing the splitting, this is the important part, right? Because this is what makes sure that your text segments aren't too big. And then when you retrieve them, you don't want to retrieve all of them. You want like the top 3 or the top 5, because you don't want to have too many tokens, because every token that you send to the LLM, especially if you're using like a pay per service one like ChatGPT or Claude or something, that costs you money in your tokens, right? So that's kind of what we call simple or naive RAG. But this, you can start to envision this can get far more complicated, because instead of just having one vector store, maybe you've got multiple places that you want to do RAG. So doing RAG doesn't always mean you've got data in a vector store. Maybe you want to do an inline web search right then and there. Maybe you want to go query something live and then aggregate those results together from all your different sources, pick the top 3, figure out which ones are the most important, and then inject that into the LLM, so that this can start to get pretty complicated. And I've got some examples I'll show here. Here's one quick one, but I'm going to go and I'll actually going to show some code here in a second to show how this works. Yeah, there's lots of stuff going on. So let's go to some code here. So I'm going to the repository was in the first slide. I don't know, Muat, if you have it, I can drop the link in the chat. Hang on, I'll go grab the link. Hang on here. Yeah, you think what an agent is doing. So yeah, so think about when we start talking about agentic, it's kind of like RAG, but kind of not. So there in the private chat here, Muath, I'm going to send you the link here to where all this code is, if you wouldn't mind posting that. So that's the link of where all this code is. For the sake of faster storage and retrieval, it's possible to use both in memory. Yeah, it's possible to do whatever you want to do, right? In memory, vector storing, caching, all the same enterprisey patterns that come with data retrieval and making your applications faster all come into play here, right? Because a vector store is just kind of like a database, right? It's just a specialized database that stores data in a different format, but at the end of the day, it's a database. So if we go, so in the example, there's this RAG here. So if I go, let's see here. So I have a chat agent, and so this is a Quarkus application. Let me start it up. All right, it's starting up. All right, so my app is up. Let me, of course, that opened in a different window. I bring this over here, make it bigger. So basically, this is a chat bot that understands how to RAG some of the Quarkus documentation. So if you were to go to the Quarkus GitHub, so it has kind of a copy of the contribution guide. So if you were to look at the contribution guide, it has a PDF version of this. Plus, it understands how to do web scraping of the Quarkus website, so we can answer questions based on the Quarkus website. So if I were to go and were to ask it, hey, I'm quirky. Well, first off, I could say, can you tell me about the weather in Boston? Oops, can you, didn't type. Yeah. So it's spitting out a whole bunch of information to me. So can you tell me about the weather in Boston today? So it's something completely unrelated to Quarkus. Right. So, I mean, it knows that it doesn't know that it's not supposed to answer those kinds of questions. So, it's here to help with questions related to Quarkus or questions about Boston, recommend using weather service or search Google, right? So, but if I ask it, what's a good Quarkus question? How do I build a REST endpoint, right? Add the dependency. So it's got some information. Of course, it's in markdown format, so it's hard to read in HTML here, but it looks like it has some of the right information, right? It's got some stuff. So let's see how that actually works. If I come back to my code, so we can look at, if we look at the logs, so I have logging turned on. So if we look at the logs and I go back to my original, I know there's lots of them. So if I go back to my first log here, so here was my question. And so I am using ChatGPT 4.0. That was my first question, just can you. So here was the next question. Where is it here? Here's my question. System, you are quirky. So it has a system message. So if you were to look at the code here, where's my chat agent? So my chat agent has a system message, which, if you remember from our first meetup, was talking about setting the context of how the agent should behave. You're a friendly question and answer agent, knows everything there is to know about Quarkus. You're friendly. If the question's unrelated, you should politely reply that perhaps they should use Google instead, and please provide references when found. So here's, when asked the first question, can you? And then if you look, it says, please only use the following information. And it's got a bunch of HTML tags and URLs and whatnot. But you notice that this part of the question isn't here. I didn't code that. So where did that actually come from? How did it get all that information? And it did that information, it got that information through this RAG retriever. And so if I just expose a bean of this type called retrieval augmenter, I can create, so I created something that understands how to search the embedding store and return 3 results. But I also have something that knows how to do a web search. And if you look at what I configured here in my properties, I'm using this thing called Tavili, which is it's an open source agent-based search capability. So I tell it that I want it to include the Quarkus.io domain, and I want 3 results. So every time the user asks a question, it's going to do a live web search of Quarkus.io with my question. It's also going to look in my vector store for 3 results. So it'll come back with 6 results, and then I can tell it how to combine those results. So in this case, it's just doing default, just put them in, but I could then use another model if I wanted to rank them. I could do a ranking model to rank or score the results and score them based on semantic similarity across all the data sources. I can also do this thing called compressing. So this compressing transformer is a way to compress. If you start to have lots and lots of data in your chat memory or your model or in your chat history, it's a way to basically tell the model to summarize itself and summarize its own history so that it costs you less tokens. So I can start to aggregate how I do all this stuff and come up with different strategies. So like here, I'm just returning everything. I could, instead of just return everything, I could do a re-ranking aggregator where I want any things that have a score of 60% relativity or not. It's always a good idea to do re-ranking because when you start combining results from multiple sources, even though maybe the top 3 results from one source might have been the 3 best results from that source in the overall scheme, they might be completely irrelevant to the question, right? So you always want to do some re-ranking after the fact if you're using multiple sources as part of this RAG pipeline. But the code to do this is actually pretty easy. And you can see here, this is where the content gets injected. If we look at the log here, here's it, boom, boom, boom. Can you please only use the following information? And here's the prompt right here. Please only use the following information. It's going through the list of content that was retrieved from all the different aggregation sources. It's grabbing their text segments and it's appending it to the prompt and returning a new user message. So it's injecting all that data into the prompt automatically. And so this is completely customizable too. You could get really crazy with this, right? Any questions about RAG? So, Muath, just quickly, how much time do I have? Do I have an hour, hour and a half? Like, when do we want to stop? Just for my own planning. All right, I'll just keep going until you tell me to stop. How's that? All right, so let's look at function calling and agents. So where RAG is for giving the model more knowledge, right? In being able to provide additional context and additional knowledge, tools or agents are about providing the models the ability to perform actions that it doesn't have, right? So you kind of just saw with RAG, we were able to provide the model and let the model do predictions or predictive text analysis on data that it wasn't trained on. The tools will give us the ability to have the model tell us to do stuff and make decisions about, hey, you told me I have a tool that says to count the number of characters in a sentence. Why don't you go do that for me and give me the answer? But there's things that you need to keep in mind when you do that as well. So first off, it has to have memory, right? You can't be completely stateless because as soon as you have tools, now you have more than one back and forth because you've got the original question, then you've got a response that comes back from the model saying, hey, go execute this tool. You execute the tool, you come up with a result, and then you send the result back, and then the model does some more stuff, and maybe it asks for another tool, or maybe it gives you the result. But essentially, there's a bunch of back and forths, and you need to have a context, and you need to do memory management. And we talked all about memory management in the first meeting, how that works and how you do evict things and how do you keep one user's memory separate from other people's memory. So that's where this starts to become super, super important, right? So it's actually again, the code is pretty easy to do. So in straight LangChain4j, when you build your assistant, you give it access to tools, and tools is just a Java class that has methods, and then you annotate those methods with this tool annotation. And this is where the description in the text that you put in here becomes super important, right? Because if you name your method something weird and like the parameter S or the parameter X is completely non-descriptive, the model's not going to know what to do with that. So the more expressive you can be by describing what the tool is and what the parameter, there's also other annotations for describing the parameters. The more expressive you can be and distinct about what the tool is, what it does, and what its parameters are, the chances are better that the LLM is actually going to behave, because you can start to imagine all the things that can go wrong here, right? The model could ask you to invoke a tool that you didn't tell it you have, or the model asks you to invoke a tool but gives you an argument that doesn't match the type. There's lots of bad things that can and will go wrong, with this. We'll talk about how to guard against that later, but essentially that they're just take it on faith, things are going to go wrong, right? So with LangChain4j and Quarkus, this actually becomes a little bit easier. You have your assistant, you register the service, and then you have this toolbox annotation, which you can delineate. If you have a bunch of tools in your application, you can give different operations access to different tools. So not all operations have access to all of your tools. So say you provide 20 different tools, maybe one operation should only have access to 2 of them. Because again, you think about every time you send a message to the model, you have to describe what the tools are, what their attributes are, what their types are, and that's part of the tokens, right? So again, we're going back, it costs, the more tools you have, the more money it costs you, and the more confused the models can get. If you tell it you've got 20 different tools, sometimes, and a lot of times, they get confused about which tool they should do for what, right? Again, I think I mentioned, like, models are like 12-year-olds trying to get a 12-year-old to do exactly what you want it to do. But if you give them 20 different choices, they're going to get confused as well, right? So let's look at some code here. Let me stop this one. So now I'm going to go into function calling, right, tools. So I've got here, right, so I've got here just a main class. And so the question is, what is the square root of the sum of the numbers of letters in the words hello and world? So models are notoriously bad at doing math, right? Because if you think about a model is predicting text based on text that it's seen before. So if you ask it what 2 + 2 is, it's probably going to give you the right answer because it's seen that in text before. It doesn't actually understand what 2 + 2 means. It just knows it's seen it somewhere before, and that the next token that it should put after 2 + 2 is 4, right? But if you ask it more complicated questions like this, it's not going to know. So it's always better, if you're going to do mathematical calculations, to provide tools for this. So here we're going to provide a toolbox called calculator, and a calculator is just another bean, and we're giving it a couple of tools. So one is calculate the length of a string, calculate the sum of 2 numbers, and calculate the square root of a number, right? So now if I go by 2, and if I do excuse me, if I run this application, so it says, what's the square root of the numbers and the letters, words, hello and world? You can see I've got logging statements in here in each of the tools. So it called string length of hello, it called string length of world, then it called add 5 + 5, and then it called square root of 10. And so now it says it's approximately 3.16, right? So if I turn on logging and rerun this, you can kind of see what it's actually doing. If I do Quarkus LangChain4j log requests true, and then log responses, right? If I rerun this, right, you'll see when it reruns, there's lots of stuff here. So go back to the beginning of the call history. So there's a bunch of back and forths. You can already see that. Let me get back to the beginning here. It says, okay, what is the square root of the sum of the letters? So this was the original request. There's no system message. And then here, it's as part of the request, it's telling you, it's describing what tools are available that the model can call. So there's 3 different functions that it can call. The first response that comes back says the assistant wants to do a tool call of the function string length with the argument hello. So now, and also another tool call with the string length called with the word world. So it's going to invoke the same tool twice with different arguments. So then my code is actually going to run. You see it here, called string length hello and world. And then another message goes back in the history, right, to say here's the tool result of this call, and of this call was 5. And it still describes all the tools. The next result comes back and says, hey, I want to do a tool call with the function called add, and the A parameter is 5 and the B parameter is 5. So you see now it calls the function. And now if it goes back, I send that result back. Here's the assistant said to call this. You see the whole history of the whole, this is the chat memory. So here's the whole history of everything that's happening. And now it's going to go send that back. And now the model responds back and says, oh, I want to do another tool call of square root of 10. So now I'm going to do that message, and I'm going to send the result of that back to the LLM. And now the LLM is going to come back and say the square root of the numbers is approximately 3.16. All right. So there was like, how many back and forths were there? 3 or 4 different back and forths between the model and my application to do this. All right. Oops. All right. So you can do all kinds of things with tool calls. So it doesn't just have to be mathematical things. So another example could be, if we go to the next example, I don't have an example, but in Quarkus, we have, and if you're familiar with Spring, similar concept, you have this repository pattern where you have a repository of operations that provide you all your CRUD operations for your database. You could put a method in there, like in this case, this is like a booking reservation system. You could put a tool that's called list bookings or cancel bookings. So now you're giving your LLM access to certain operations that are there on your database, right? So you could find customers and get results, or can't actually perform mutation operations that mutate data. So you got to be careful, but it's actually pretty easy and possible to do, right? And so you can also give access as a tool to other remote services. So in Quarkus, if you were to build a like a client that makes REST calls to another service, in this case, some weather forecast service, you would build an interface which looks like this, right? And this would be, you could, get an instance of it out of the context and call it in your own code, and it would make a REST request. Well, you could just annotate that with tool. And now that operation where your app is making a remote request to another app becomes a tool that's available to the LLM to be called, right? So you can start to see how you can start building these tools together to form this agentic architecture, right? Where your application can now do coordination and reasoning between tools and decide what to do. But the important part here, so this isn't, when we start talking about agentic architectures, the algorithm of what to do and how to do it is either written in our application or it's computed by a model that's part of our application. So we haven't quite completely leaped to this fully agentic thing yet, but we've got a single application which can make decisions and workflow decisions and patterns about how to execute different services or how to coordinate different services together based on what the question is or what's in the context, right? So there's patterns like the workflow patterns where this blue box here that says AI agent, this could be your own code and you can have complete control. Maybe you have access to a bunch of different agents that do different things, but your code is in control of the workflow. Like, do this with my city extractor, then from the result of that, do this and then do that. Or that AI agent could just be another LLM invocation that just has access to these tools, and you're letting the agent fully automate the interactions between these other things. All right. So yeah, so like in this case, we have like a weather service. So if you ask it for, what's the weather in Boston? Well, first it's got to get, the way the weather service works is it takes latitude and longitudes, right? So you need to extract the word Boston, extract the city from whatever the sentence is, right? And so you could do that with this city extractor agent. Once you have that, then you can have to get the latitude and longitude. So maybe you have another geocoding tool that, given the city, knows how to give you the coordinates for that. And then you have another agent which knows, given those coordinates, knows how to do provide a weather forecast. And at the end of the day, you have this agent up at the top here that just has access to all the other agents. So all of this is completely non-deterministic. So the user just says, what's the question, or what's the weather in Boston or in Riyadh? And it invokes all these different agents in the way that they think they need to be invoked. And so what could possibly go wrong, right? We're just adding to the complexity. What could possibly go wrong? So we need to make sure that when things go wrong, because things are going to go wrong, that we have the ability to troubleshoot this. And this is where observability and tracing and all that fun stuff comes into play, right? So if I have this service here, so let me go, and if I fire this one up, right? So what this is going to do is it's going to pull some images here. So I have a service that says you're a professional poet, and I'll write a poem about things. It should be so many lines long, and then email it to me. So, and then it has access to this email service, right? And then the email service just has a single endpoint called writing a poem. So as soon as this thing starts up, we'll go look at what this thing does. It's not up yet. It's going. So this is actually starting up a full LGTM, the Loki, Grafana, Tempo stack with all the open telemetry and collector and all that stuff. So you can start to get some observability in here. So now if I do, oops, 8080, email me a poem. It says, okay, here's the poem. So I'm going to go into the Quarkus dev UI. I'm going to hit the D key, and of course it opens in a different window. Let me bring this over here. So in the Quarkus dev UI, one of the extensions we have is called MailPit. So MailPit is awesome for if you want to do email and email testing. So you can see here, there's an email waiting for me, and it's the same email that the poem that it wrote for me. But the other thing that's neat is now I've got the whole observability stack here. I can come in here, I can go into the Grafana UI. I can say, let's do explore. I want to explore Tempo. I want to do a search where my service is here. And I want to do a get to email me a poem. And let's run the query for the last hour. There's one interaction. I really hate the Grafana UI, but now you can see here's all what happened here. So here's the completion call to ChatGPT. Here's how many tokens were used in that call. Here's there was a tool execution that actually did the email. Then there was the actual tool that sent the email. Here was the content that it sent. It called the send an email, and I can drill down right into the logs just by clicking the button. So everything is correlated here together. So you can start to see when things go wrong, you can go back to any particular question and see what happened through the trace, what the parameters were, how much time it spent. And if you start to get into this agentic architecture where you've got one service calling other services, this tracing flows through all of your different services, so you can start to troubleshoot and trace. It's super, super important in these types of systems. And I alluded to as well, I have a whole another talk that I'm preparing about how to use this, how to combine observability with auditing, with scoring and replay, so that you can answer the question. If I have my system, and if I change my model or I change my prompt or I change something, how did I get better or worse? And it uses kind of combines all of these things together into a homogeneous solution, which something I've been working on for about a year now, and it's finally getting very close to fruition. Yep. So tracing is super important. I showed that. There's other kinds of tools that are available. So I showed web search before as part of RAG, but you can also use web search as a tool. So it doesn't have to be as part of a RAG pipeline. So you could do function calling search. So I've got an example here that does a web search. So I can say, was there a Java version released in 2025? Right. So I've got two different assistants here, one that doesn't have access to tools and one that has access to this web search tool. And web search tool is just something that comes from LangChain4j. So it already kind of knows. So without the tools, was there a Java version released in 2025? As of my last training in October 2023, I don't have any information about 2025. Whereas when it uses the web search, it can actually go out to Google or whatever and do a web search before it answers the question. And this isn't technically RAG. It's using web search as a tool. So it says, yes, there was a Java 25 was released in 2025. Right. So web search is kind of interesting because you can use it as a tool or as part of a RAG pipeline. So things can go wrong, right? So prompt injection. So being able to understand, like, to hide against prompt injection, especially when you get into this agentic architecture, putting security controls, if it's accessing data, putting controls around who has access to do what. And that's why auditing starts to become very important, to both look at the parameters as well as looking at distinctions between things that are read-only and things that can actually mutate state. So, going back to like my customer support agent, if I want to have my chatbot be able to cancel bookings, you better make sure that it's not going to do the wrong thing or doesn't have access to mutate data that it shouldn't. And that maybe only certain kinds of users have access to that data. So coming up with that stuff starts to become really, really important, right? Any questions about tools? Because now we're going to kind of take this and this concept. So we're kind of building on concepts, and now we're going to take that concept and extend that to MCP or Model Context Protocol. And again, Muat, just tell me to stop when we run out of time here, right? All right. So MCP is something that came out of Anthropic. It stands for Model Context Protocol. So if you start to think about this architecture of agents talking to each other, MCP was a protocol definition which describes how these things should communicate, like a protocol for defining the interface as to like how you should make the request, kind of like HTTP, but specifically putting a protocol around these different things. So instead of where I took tools and I exposed tools to the LLM within my own code, how could my application now self-discover other tools that might be remote service invocations that live, if I'm in Kubernetes, maybe I'm exposing different things in my namespace, or maybe I want to pre-configure it with other tools, but maybe those tools are written in different languages. Maybe there's one service is in Python, one is Node.js, mine's Java. I can communicate with those tools. Each tool can be its own independent service, kind of like microservices, right? Where we can each tool is independently from anything else, and we can invoke them remotely. So conceptually, it's like a tool. It's just how you invoke it. It's now kind of like an RPC call instead of the model telling you to call something within some method within your own code base. At least that's how I think of it, right? So the client can invoke a tool, get the response. It's kind of like function calling, but it involves an invocation, and there's a couple different ways that invocation can happen. And the tool can be anything. It can be a web service, it can be a RESTful service, it can be another process that's running on the same host. It can expose data, you can access it through URLs, you can the service can predefine specific prompts. So in the case, so say I want to do, similar to a Docker, it's kind of similar to a Docker registry, but it's a way to have different services that are up and running, and they can describe what their capabilities are, and you can self-discover those capabilities. So you could deploy your app into an environment that is, maybe your app is the only app that's there. And over time, maybe you deploy another service into that same namespace, which is an MCP server. Now your first service can automatically self-discover that second service, and then know maybe it's a stock trading. Maybe you're doing stock trades. So maybe your app only knows how to trade equities, and you want to be able to trade currencies. So maybe you deploy a currency trading app that exposes itself through MCP. Now the app that's already there now suddenly has gotten superpowers. I kind of, if you've seen the movie The Matrix, you know, when they plug something into Neo and he closes his eyes and like, hey dude, I need to know how to fly a helicopter, and they plug the thing in and suck in the information, and now he knows how to fly a helicopter. It's kind of like that. Like now, just through self-discovery, the app now knows how to do new stuff through a remote invocation, if that makes sense. It's kind of the best way I can explain it. The way the transport works is it's either over standard IO. So if you're doing inter-process communication through pipes and, you know, input and output pipes, or through server sent events, or actually now instead of server sent events, it's going to be streaming and WebSockets and whatnot. But regardless of which way you're doing it, the communication is the same. Everything is through JSON RPC. The interface, the request, the response is the same. It's just, are you communicating with the other thing through standard IO? Are you communicating with it through HTTP? Right. It's kind of, if you've been around long enough to have dealt with SOAP in the past, which was like this protocol over XML over HTTP. It's kind of somewhat quasi similar to that. From your app's perspective, or from the LLM's perspective, it looks just like a local call, but it's really a remote invocation, right? And it's a way to give access to different resources. So let's look at a couple examples here, right? So let's go look at some examples. Stop that. They just kind of out of order here. So the simplest example is here. So I have this. So this is just using straight LangChain4j. There's no Quarkus or anything in here. So I want to communicate with some process. I want to give that process access to some directory. I'm going to call it the playground directory on my file system, right? And I want to give that through through standard IO. I actually want to start a file system process, which is written in Node.js, right? So I'm going to start this Node.js thing, and I'm going to give it access to that. And I want it to write a Python script that's going to do something for me, right? So if I, wrong directory. Right. So if I run this, and I want it to turn logging on. Oh, what happened here? Could not run npm. Yeah, I think I have an issue with npm on my machine. I don't know that I'm gonna be able to run this. I was trying to play with this earlier. I've got some issue with npm. Oh, here it goes. So you can start to see. So it actually started this process, from the model context protocol, the server file system process, because it wasn't running already. So it started it, and it gave it access to the path that's going to log the events. I'm going to give it the transport. I'm going to build a message history, and then I'm going to build my assistant, right? And so my assistant looks just like all the other assistants we've built before. We didn't even give it access to tools. We just, because we're using tools, or because we're using the agentic or the MCP framework part of LangChain4j, it just kind of self-discovered the fact that it has access to these tools that I've given it access to. So you can see the NPM server knows that it has access to certain directories. It knows what capabilities it has. And so now it says you have tools to interact with the local file system, write a Python script. The system message was, you have tools to interact with the local file system and the users. The only directory you can work with is playground. If the tool tried to access a directory outside of there, it would throw some kind of exception, because the tool knows it can only have access to a certain directory. And these are the tools that it discovered, because part of the MCP protocol is when you ask an MCP server what capabilities it has to have a way to express that. So it can tell, any MCP server can tell you kind of like its inventory of what operations it has available to it. And so this app will self-discover that. So it has all these different tools that are available to it, and they look like local tools. It's just that they get kind of piped out to a remote request. And when the request happens, you can see it wrote some files, and if I go look at the directory, now there's a sum.py and there's a Python file there, right? So the tool actually wrote that file for me and saved it to the file system, right? Similarly, I could do, using, instead of writing all of this code myself to tell it where the tools are, I could do that through configuration. I could do the same thing with very similar code, but I could remove all that kind of boilerplate stuff by using Quarkus. And I can say, so here's my run, here's my answer, here's my assistant. I just want to say, hey, this operation has access to the entire MCP toolbox, whatever that means. And that what MCP toolbox is through configuration, I can define, it's basically the same thing that I defined in code before, but now I can define multiple server interactions or multiple clients to interact with, and my model or my operation will automatically get access to these. There's also configuration where I can just tell it to self-discover stuff, like give it a URL and it can self-discover what the operations are, right? I can also build MCP servers. So if I want to build an MCP server, there's a framework for that. So if I want to build a weather service, so I build an app which knows how to make REST calls to a weather service, I can expose these as tools, right? So that when I ran my MCP server, I could then call it and it would self-discover those operations. So now I can start building clients and servers that are in different languages and all that fun stuff. Right. So again, what could possibly go wrong as we start adding to the level of complexity here? There's lots of stuff that can go wrong when these tools are part of your own application, and we just exasperate the amount of things that can possibly go wrong when we start doing these remote calls and having the models making decisions about whether to call remote servers or not, right? So whether or not to do MCP is kind of like, have to make a decision. Everybody's doing it. It's kind of like the thing now. There's all these MCP servers out there, registries. How do you know whether an MCP server is respectable or not, or whether it does bad things? Who knows? This is still an evolving ecosystem. Is MCP going to be the standard, or are there going to be multiple competing standards? Who knows? It's, everything is still so new, but we have to worry about security, right? Because these MCP servers, it could say, in its descriptor that, hey, I add 2 numbers, but in my implementation, I also read your ID RSA file and I send it back to my bad server, right? So we call that tool poisoning. There's all kinds of security related things that can go wrong here. So take it like a grain of salt. Don't trust anything like off the internet. Like when you just say, oh, I'm going to NPM start this server because it looks like it can do something for me. Be careful. It's kind of like the guidance. If you don't know what it does, then you probably don't want to use it in production, even if it gives you good stuff. So that's my spiel on MCP. Do we have time for one more section, Muaf? We can talk about guardrails. Yeah, okay. So guardrails it's a pattern that we can start to use to help, when all these bad things happen, how do we stop or try to maybe not necessarily stop, but know when bad things are happening and kind of control the chaos? Is there an authorized MCP server? So you can start to build security into, and that's kind of what A2A, I know Google has this A2A framework that's out there. You can start to build security through like OpenID Connect, and like the same way you would talk to REST services through authentication and protecting your operations, you can do that through MCP as well. So you can start to build MCP servers that require, auth tokens and all that fun stuff. So all the same concerns that you have with web applications, you have all those same concerns with MCP, right? So guardrails. So that you've probably heard about at least one of these things in the news. My favorite is this one in, I forget what state in the US it was, but somebody was chatting with a chatbot for a local Chevrolet dealership, and they got him to sell him a Chevy, that's $76,000 Chevy Tahoe for $1, through prompt engineering and whatnot. And it went to court, and the dealership had to sell them the car because they claimed that the dealership claimed, oh, it was a chatbot, it was a malfunction, and the courts ruled that, oh, it could have been a malfunction, but the user thought they were talking to a real person, and it's acting on your behalf, so you're liable for whatever the thing says. Similarly, there was a thing with Air Canada about their chatbot telling them about refund policy that they tried to not enforce, and that lost in court as well. But the point is, there's lots of these things, and you see them every day, where people are smart enough to kind of outsmart a chatbot and get it to do things that it's not supposed to do, and that's what you need to be careful about. And so guardrails are a way to not to get around it, but to help guard against that. So think of it as, so whenever there's an input to a model invocation, there's an output from a model invocation, and a guardrail is essentially a way to detect bad input. So before stuff actually gets sent to the model, maybe you've got a blacklist of words, or maybe you can do prompt injection detection beforehand, or you can do all kinds of stuff before the data is even sent to the model. Once it comes back from the model, you can then inspect the output. Hey, is it actually what I want? Like if I ask the model, hey, give me some result and give it in JSON format that looks like this, and the result doesn't look like that, then you should be able to tell the model, hey, I asked you for something that looks like this and you didn't do that. Try it again, right? So being able to do these kinds of things. So input guardrail, there's two types of guardrails, input and output. Input guardrails are pretty easy. It either passes or it doesn't, right? You apply the guardrails. If any of the guardrails don't pass, then the model doesn't get called and your application has to do something. Output guardrails have a couple different outcomes though. So there's successful, so everything's good, and the response is just passed on to the next guardrail because you can chain them, or to the next caller, or back to wherever it came from, and everything is good. The guardrail could return a fatal error, say, wait, you tried to just steal my identity. We're going to report you, and we're going to stop executing everything from here on out. We're going to stop the request, right? They could be similar to security filters. If you think of it theoretically like a filter chain, like a servlet chain or a filter chain, you've got a chain of things. So you've got a chain of input guardrails that execute, and assuming all of them pass, then you make the real request. And when the response comes back, then you've got a chain of output guardrails, and each output guardrail can exit with different statuses. And these are the 4 statuses. But what's interesting, if anything other than success happens, so let me just describe them. So the other one could be fatal, you stop. One could be a retry, just basically say, what you got back isn't good, but because models are non-deterministic, you could just execute the same request and get a different response. That might be okay, and that's fine. Or you can reprompt the model. So you could add another message to the context to say, I like to use the JSON example, like, I expected JSON that looked like this. You didn't give that to me. Please respond in a way that gives me a JSON structure that looks like this. And then if that next response comes back and it looks good, you then have to go through the entire chain of output guardrails again, because if this was like the last guardrail in the chain, that new response could have violated the first guardrail, right? So just because you got to the end and the reprompt was successful, you've actually got to go back through them all again until you can go through an entire iteration through the entire chain and everything passes, right? I'll talk a little bit. I'll show some examples. I'll talk more about that. So you can do this. So this is supported now. I actually implemented this in LangChain4j a couple of releases ago. So this is in straight upstream LangChain4j. To build your input guardrails, there's an interface called input guardrail. There's a couple different method signatures you can override depending on how complicated you want. If you just want to look at the user message, there's a simple validate method. So in this case, with an input guardrail, you're either successful or you fail. If you want to do it in Quarkus, it looks exactly the same. It's the same input guardrail interface. It's the same classes, except the only difference is you have to turn it into a beam. And I'll show you why in a second. So in In upstream, you just do this, and in Quarkus, you just add application scope to it, right? Otherwise, it's the same code. It's same imports, same classes, and everything. Similarly, with an output guardrail, there's an output guardrail interface. There's a couple of different flavors of method signatures, but essentially you get this. It's actually output guardrail request. I'm going to update the slide here. There's an object that has like what the user message was, what the chat history is, what the response was. There's all kinds of information. There's a context about the call. There's lots of information that you can use. So in this case, it's a guardrail that makes sure that the output is all in uppercase, right? So this case, it says if it's all uppercase, it's successful. Otherwise, it's a reprompt where, because you know at this point that the message it should be all uppercase and it wasn't. So you can actually tell the model, do everything, send the entire history back that was there, but say, hey, the output must be in uppercase. Please provide the output in uppercase. And so this will trigger a reprompt to the model, and it'll reprompt it a set number of times that's configurable. And if after, say, 3 or 4 times, it still doesn't give you the right answer, then you fail. And it keeps the guardrail implementation keeps track of that for you automatically. And again, the difference between upstream LangChain4j and Quarkus is just the way you make it a bean in Quarkus, but it's the same code. So in LangChain4j upstream, you just declare that this guardrails only work on AI services because it's kind of a higher level construct than just using the model directly. So you can only use this feature with the AI services. So you can declare your input and output guardrails either on the interface as a whole, which then the guardrails would be applied to every operation, or you can apply it just on particular operations. It's up to you. And then you can chain them together. And in Quarkus, it looks like this. It's exactly the same. And it just works. Right. And then there's the testing. If you want to build guardrails like everything else, you should unit test them. And there's a part of LangChain4j, there's a unit testing framework that's built around AssertJ for testing. So like being able to test that results are fatal or have failure messages with reprompts and whatnot. There's a whole testing framework in there that's wrapped around AssertJ. And it's the same testing framework in Quarkus, that you would use, right? So let's go look at some of these. Let's see here. SP guardrails. So if we just look at it in straight up LangChain4j, right? I've got an assistant. I've got some input and output guardrails. I've got my user message. I've got the application, which just says, say hello world. 6.1. Right, if I run this, it blows up. The uppercase guardrail failed with the message. So when an input guardrail fails, it throws an exception that if you don't handle it in your application, it blows up the operation. So if you'd have to catch it to do something with it. So it's got the guardrail. I can either return success or failure, and then I've got the output guardrail. So if I switch my message to this, and I rerun it, I must provide a model. I'm not sure what it's doing here. Say hello world. You must provide a model parameter. I'm not sure what it's doing here. Anyway, I'm not going to debug it live. If I switch to this one. Yeah, not sure what the error is, but essentially you can start to see if I were to change and switch my input guardrail, or take my input guardrail out and go back to this first guy here. Yeah, I messed something up. Anyway, you get the idea. So you have input guardrails, output guardrails, and okay, as I said, the output guardrail request, you can see it comes right from LangChain4j. has a bunch of stuff. It has the response that came back from the LLM. It has some parameters about it. It has the memory. It has if there was augmentation. So augmentation is when your RAG pipeline has. If you're augmenting the prompt through a RAG pipeline, you have the result of that augmentation. You have whatever if the user message was templated, you had variables in it. You have the original template, and then you have a map that has all the variables. You have this context that talks about the invocation. So every invocation, the entire invocation from start to finish shares a unique ID. So this kind of goes back to the auditing and the tracing. So every invocation shares a unique ID. So you could start to correlate guardrail invocations with an overall invocation, which interface and method it was called from, what the arguments were, if it was part of a memory. So there's all kinds of things that are here that you have access to if you need to, right? Yeah, I think again, I don't know how much time we have here. If we have time to go through this, it's kind of like the last section. I think we can do it in a couple of minutes. So now how do you test it? So I've alluded to a couple of times. How do you test your applications that talk to these LLMs, right? We're all in the Java world. We're all used to mocking, right? We do mocking or unit testing, but is that the right thing? Sometimes, sometimes I'll use mocking or a tool like WireMock. Like if I don't care about the LLM piece and I just want to mock out the LLM piece to ensure that the rest of my application, it doesn't matter what it responds with, but just the rest of my application knows how to handle and do something with it, then sure, mocking out using WireMock or something and stubbing out the AI part of it, it is kind of like a database. But what if I need to do evaluation scoring or look at how good are the results that are coming back, or are the results that are coming back based on what I send it acceptable? And so this is something that's built into Quarkus specifically. This doesn't exist in LangChain4j yet. This is just in the Quarkus implementation or the Quarkus extension for it. So the first part of mocking is just kind of like I said, using so say you had some service, because it's an interface, you can just inject a Mockito mock of it and use it, right? That's pretty easy. You could also do judging. So maybe you have a separate model that's acting as a judge. So this is another pattern out there. You have these things called judge models that can judge given a bunch of responses and some assertions, like it should be a summary of input text, shouldn't have more than 5 bullet points, so on and so forth. I can run that judge and do an assertion that the response I got matches those assertions, right? So that's another way that you can do this. Maybe you need to be able to score. So this is kind of going down the road of what I was talking about earlier. How do you know if you got better or worse? Well, first overall, you need a way to score something, right? So you need to know at what percentage does a particular response meet or a particular set of expectations, right? So if I want to score, over time, I want to be able to see, did I drift? If I made this change, my score went from 70% to 65% if I changed something. So I need a way to be able to score these things. And again, we have this in Quarkus as well. This, even though I'm showing it here as like a unit test or as part of JUnit, you probably wouldn't have this as part of your application. This would probably be something external from your application that you would run, I don't know, monthly or after a release or something, but you would have some kind of evaluation project somewhere which knew how to take samples and score. So where do you get the samples from? That's a great question, right? So do you handcraft samples or do you get them from your production system? And that goes back to the whole observability thing and the auditing thing. You have to, if you want real examples from your real production system, well, then you've got to be storing those and capturing them somewhere. Again, this tying all of this stuff together is kind of what my talk that I'm doing in February is all about in a way to do this. So unfortunately, I don't have it all built yet to be able to show, but it kind of ties the auditing part, the scoring part, the judging part, the observability part, the guardrails. It ties kind of all these pieces together into a framework where now I can run these things. I can get access to my samples. I can play back things that have already happened in the past, score them, and then replay them based on some change that I've made, score, and then do score comparisons and plot score comparisons on a chart and stuff like that. So that's kind of where all this is going. I feel like this part of it is, we're, as an industry, we're just dipping our toes into it, and we haven't quite gotten there yet because we're still experimenting with MCP and agentic and whatnot. I don't think we've kind of gone this far. I don't think we're here yet. And so yeah, so that's all. So the I can share a little bit. I can't run it right now because I'm still in the middle of building this thing, but this all-in-one thing essentially is a chatbot which deals with insurance claims, but it has other agents in it that uses guardrails, but then it captures and it observes all of these events and captures them so that it can play the events back and it can score them and reevaluate if I wanted to change the model and all that fun stuff. So the link for this is down the bottom of the slide. It's a work in progress. It's what I'm working on now. It doesn't work yet. There's different stages of it. But yeah, I could try to run it if you're interested. I can see if it'll work. Let me see here. This is like hot off the press here. Let me pull the most recent changes here. I can't even guarantee that it's going to compile, but we'll see. Let's see what happens. So it's creating a bunch of containers. So I have, again, the entire observability stack. I've got open telemetry and all that fun stuff in here. So I've got all that. When I showed you the auditing stuff, let me find where it is here. Excuse me. So I have, where is it? So I have, where is it? Bum, bum, ba-dum. I've got a bunch of guardrails. I've got my notification service. I've got mappers. I've got my events. Let me find, it's in here. So in my repository, I'm observing all of these events. Remember that I talked about the auditing, and then I'm actually persisting them into the database. So I'm storing them as in tables. So when I go into this app here, of course, it opened in another browser window. Pull this over here. So I go into here. I can say, can you please deny this claim? So I can take action. I forget which model this is using, but while that's working, I can then go back to the dev UI in Quarkus. Again, it opens in another browser. So it's telling me it can't do it for some reason. That's not important. But if I come to my dev UI, I can then go to Grafana, and I've built a specific, excuse me, a specific dashboard called the AI dashboard, where I can now start to look and visualize how much, like if this application were up and running for a period of time, how much it's actually cost me in tokens, how many interaction failures I have, how many tool invocations. It's when it didn't do it. Guardrails. So guardrails are interesting because guardrails are supposed to guard against bad things happening. So if you have your guardrails configured to run maybe 3 times before it fails, if you start to see that over time, like maybe in your initial release, your output guardrails, they should run at least once, right? Because it's going to run through them the first time. But after you make a change, maybe you start to see on average per execution, your guardrails are executing twice or 3 times or 4 times before it produces the correct answer. Well, something's not right. It might not be broken. Your app might still be working, but it's costing you more money. It's costing you more tokens. Something's not right. So keeping track of token counts and all that fun stuff here. So this is kind of where I'm going with all this, and then being able to play things back, because then I can come in here into my database. I can look at all my audit events and I can correlate them by interaction ID. So if I actually go, I built a REST endpoint. So if I look at where's Swagger UI, if I look at Swagger UI and I want to look at all of my interactions, I can play back all of the interactions. And if I have a particular interaction ID, like one interaction, I can play back all the things that happened. So here was the original user message, system message, and that was I guess that was the only interaction and the result. So there weren't any tools or guardrails or anything that were executed, but you could actually play back the entire history of events of things that happened for a particular interaction. The guardrail happened, the tool got invoked, something bad happened, and so on and so forth, and then be able to play that back later on. So that's kind of where I'm going with all of this stuff. So hopefully by February, I'll have all this worked out and I'll have a whole presentation that I'd be happy to come back and give. So in conclusion, so we talked about a lot, and I didn't even get into agentic architectures and very much. There's a whole agentic framework as part of LangChain4j. We could do a part 3 another time. I have to learn a little bit more about it. And that's kind of it. I think that's it for this. We finished it. I don't know why you can't see the thank you slide.
Yeah, it has come. It has come.
There it is.
Yep.
Yeah, so that's it. We made it.
Yeah. Thank you so much. I'm really, really happy for completing part 1, part 2 as well. There's lots really to learn and discover. It's amazing, really. It's amazing. I was really, really astonished by the simplicity that Quarkus and LangChain4j is bringing to the community. So simple stuff. With a few lines, we have the whole stuff is running. It's amazing, really. Yeah.
Yeah, I've dabbled with, because I know everybody talks about like Spring AI and whatnot, and I've played with Spring AI a little bit. The thing there's 2 things I really, well, I guess I'm biased towards Quarkus anyway because I'm on the engineering team, but in general, there's 2 things I really don't like about Spring AI. One is it doesn't have the declarative approach. So like being able to build these higher level like AI services with operations, it follows the same pattern like with like REST template and web client and all that stuff. The other part I don't like is all of these things that do specific things like guardrails or observability or events. They all do these things called advisors, right? It has a generic advisor, which is kind of like a filter chain. Like you have to create all these, and they're very general. It's like, okay, I build an advisor and I have to put them all in the right order, and do I stop processing or do I proceed to the next advisor, and then I have to handle the result? But it's so generic, it doesn't have context about what that advisor is actually doing. Whereas with LangChain4j, we're trying to be like, a guardrail has a very specific purpose, and it happens at a very specific time in the workflow, and you don't have to worry about the ordering or the wiring between a guardrail or firing an observability event, right? It's just taken care of for you by the frameworks. For me, those are the two biggest pieces, and the 2 biggest gripes I have with Spring AI is the generic, that it's too generic, I think.
Yes, I see. With regards to, I think they released a new framework. I was like watching Rod Johnson was talking about Embarrel AI. I don't know what is this like about. Can you please throw some lights on this?
Yeah, I haven't dabbled with it enough. I mean, I could be totally wrong here, but my understanding is it's a framework that sits on top of Spring and Spring AI for building agentic architectures. And we have something similar in LangChain4j too. I haven't been part of it, so I'm not as familiar with it yet. And that's what I've got to do part 3. I've got to get up on that too much learning, right? It's always something new to learn.
Yeah, sure. So my question is also regarding the now how far we are from being LangChain4j or Quarkus being mature enough to also to baseline it into our protection applications, or it's already matured enough.
I would say it's already mature enough. I mean, it's not at a
Nice.
beta or an RC. I mean, LangChain4j is almost at a 2.0 release now, and same with the
Nice.
Quarkus integration.
Awesome.
And I
So
think you're going to start to see vendors starting to offer support, like industry and support around LangChain4j. I can't say too much about that, but I think in the near future you're going to start to see some vendors starting to offer commercial support for it.
nice. So also with regards to like comparing Quarkus and not Quarkus actually Lang4j with the Python LangChain, the Python framework. Like, are they like competing each other, or we are always like behind, or we are in the same race, or how we can convince like the community that we are also ahead, we are also like in the right track.
Yeah, so this kind of goes back. I talked a little bit about this in the first one. So LangChain came around, and then LangChain4j was like, oh, what LangChain is doing is very interesting, building an abstraction layer. But the way you do it in Python and the way you do it in Java is very, very different. So at this point in time, there's no relationship other than their name is close to each other, right? So LangChain4j is just a Java framework and abstraction that's framework agnostic for abstracting LLM and AI concepts, whether it's agents or MCP or models or vector stores or whatever. It's just it has like this inspired by relationship where it's not necessarily tracking what LangChain is doing. It's got its own roadmap, and it's based on what the community and what the Java community needs and wants.
Sure. Nice. I see. Yeah, I think I think we are done with the questions. Again, thank you so much, Eric. It was really amazing, a wonderful presentation. Very good demos. Demos are really good, straightforward. If you have any final words, Eric.
No, that's it. I'm happy. Like I alluded a couple times to this mega thing that I'm trying to put together. I'm happy to come back and talk about the whole concept of how do you know if you got better or worse once I get it done, because I've been chasing that for about a year now, and in my my spare time. So
nice, amazing. Are we like expecting a visit from you to Riyadh in the soon, like in the upcoming, maybe next year, or are we in the schedule?
If you want to pay for me to come over, I'll be the closest I'm going to be in the near future is Morocco in 2 weeks.
Yeah.
I'm going to be at DevOps Morocco. Awesome, and I'll be at JFocus in Sweden in February. But past that, I don't have any international plans. If you got money and you want to pay for an air ticket, I'm happy to come.
Sure. All right. Thank you so much, guys. Really, thank you, our audience, for attending this talk. I will send all the details. We'll send also the recordings. So good night for now. Thank you so much, Eric. See you guys.
You're welcome.